Alright, this LeetCode question is called Palindrome Linked List. It says, given a singly linked list, determine if it is a palindrome. The first example they give us is the linked list 1, 2, and the result is false because that cannot be read the same forwards and backwards. And then the second linked list they give us is 1, 2, 2, 1, and that's true because that is a palindrome. And then it says follow-up. It says, can you do it in O of n time and O of 1 space? And that is exactly what our solution will be. A palindrome is something that could be read the same forwards as backwards. And I have an example here. We have 5, 4, 3, 3, 4, 5. We see that if we split it right down the middle, and you start going from left to right and right to left, they're the same. You have 5 on this end and 5 here, 4 here, 4 here, 3 here, and 3 here. One way we can determine if this is a palindrome is by splitting it in half like we've done already, and then taking the second half of it and reversing it. What's the reverse of 3, 4, 5? It's 5, 4, 3. Now, if we just traverse these one by one and compare them, if at any point the numbers aren't the same, it's not a palindrome. But if we get to the end of the second one and everything is the same, then it is a palindrome. It'll look something like this. Is 5 the same as 5? Yes. Is 4 the same as 4? Yes. And is 3 the same as 3? Yes. So this is a palindrome. This technique will help us to determine if two linked lists are palindromes. Alright, so the way we're going to do this is to use two different pointers. We'll have a fast pointer and a slow pointer. What's going to happen is that we're going to move the fast pointer at twice the rate of the slow pointer, so that when the fast pointer gets to the end of the linked list, the slow pointer will be exactly halfway. Let's see how that works. So we're going to move the fast pointer 2 nodes and the slow pointer 1 node. Fast pointer 2 nodes, slow pointer 1 node. And as you can see, the slow pointer is at the midpoint of the linked list. So now we want to reverse this half of the linked list. So when we reverse that half becomes 1, 2, null, and we move the slow pointer to the head of this linked list. We also remove the fast pointer to the head of this linked list. Now let me show you what happens to the right side of the top linked list. Since we've reversed the linked list, null goes away because nothing's going to be pointing to it. So this is roughly what it's going to look like when it's reversed. But since nothing in the top linked list is pointing to this anymore, this one actually goes away too. So this is what you're left with. The first linked list is now 1, 2, 2, null, and the second linked list is now 1, 2, null. So now all we have to do is compare each node by node. So we say, does 1 equal 1? Yes. Then we move up a node. Does 2 equal 2? Yes. So then we move up a node again. And now since we're on null in the second linked list, we stop. And since we've gone through every node in the second linked list, that means every node was the same, which means that our original linked list is indeed a palindrome. Alright, so let's get to the code. What LeetCode has given us is a function named isPalindrome, which accepts a parameter called head. Head is just the head of a linked list. So remember, the first thing we have to do is we have to have two different pointers, one being the slow pointer and one being the fast pointer. So we'll say let fast equals head and let slow equal head. So we'll have a fast and we'll have a slow. Now we'll have to move the pointers until the fast pointer is at the end of the linked list. So we'll say while fast doesn't equal null and fast.next doesn't equal null. We need both because in a linked list with an even number of elements, like the linked list we have now, the fast pointer will end up on null when the slow pointer is at the midpoint. But in a linked list that has an odd number of elements, the fast pointer will end up on the node right before null for the slow pointer to be at the midpoint. All right, so remember we're moving slow by 1, so slow equals slow.next. And we're moving fast by 2, so fast equals fast.next.next. That would look like this. Fast will move 2, slow moves 1, fast moves 2, and slow moves 1. Okay, now we have to move fast back to the head. So we put it there. That looks like this. Fast equals head. Then we have to reverse the second half of the linked list. We'll say slow equals the reverse of slow. Notice right now, slow is a linked list of 2, 1, null. When it comes to this reverse method, I'm not going into detail in this video about how to reverse a linked list. Just know that I have that video and I'm going to link it in the description down below. I will, however, quickly implement it at the end of this video. All right, so when the second half is reversed, it's going to look like this. It's going to end up being 1, 2, null. And that's going to be the second linked list. And remember that since these arrows are now reversed, because we just reversed it, nothing will be pointing to null. And if you look, nothing's actually pointing to the last number 1. So the first linked list will actually look like this. Okay, so now we're going to compare the values of the nodes in each linked list to see if they're the same. So we'll say while slow doesn't equal null. We'll use slow because it's the shorter of the two. We're going to check if slow.val doesn't equal fast.val, then we'll just return false. Because if the values aren't the same, then it's not a palindrome. But if they are the same, then we just have to keep traversing the linked lists. So we'll move up slow by 1, slow equals slow.next, and fast by 1, fast equals fast.next. That will look like this. We start here. Are the values the same? Yes. So we move them up by 1. Are they the same? Yes. We move them up by 1. And now since we've gotten to null in the second linked list, we can just stop because now we know that they are equal. So since they're equal, all we have to do is return true. All right, so all there's left to do is to implement the reverse function. Remember, all this is doing is reversing the second half of the linked list. So we'll say let reverse equals function, which accepts a linked list. Let previous node equals null. While head doesn't equal null. Let next node equal head.next. Head.next equals the previous node. The previous node equals head. And then head equals the next node. Then at the very end, we just return the previous node. Let me just fix this semicolon. Okay, let's run the code. Missed an ampersand up here. Run it again. Looks good. Let's submit. All right, our solution was faster than about 94% of other JavaScript submissions. As usual, the code and written explanation are linked down below. If you liked the video, please give it a like and subscribe to the channel. It helps out a lot. See you next time.